So far we saw that the summation of x to the n start from 0 to infinity, which is 1 plus x squared, x to the third, and so on, which forms a geometric series as long as the absolute value of x is less than 1, is convergent to the function 1 divided by 1 minus x. We also saw that the summation of -1 to power n, x to power 2n, and start from 0 to infinity, which is equal to 1 minus x squared plus x to the fourth minus x to the sixth plus the rest of the terms, as long as absolute value of x is less than 1, is equal to 1 divided by 1 plus x squared, all using algebra and this geometric series. Now we want to find a power series representation for the following function. Representation for 1 divided by x plus 2. We're going to use the following, what we did before, and try to find a power series representation for 1 divided by x plus 2. We're going to do a little bit of algebra, everybody. Our goal is to try our best to rewrite. We want to rewrite 1 divided by x plus 2 in the form of 1 divided by 1 minus a quantity. This is your goal, using algebra to convert 1 divided by x plus 2 to 1 divided by 1 minus a quantity. Why is that? Because if I have 1 divided by 1 minus a quantity, I can follow this pattern. Okay, let us try our best in using algebra and rewrite this. First of all, 1 divided by x plus 2 is nothing but 1 divided by 2 plus x. If you factor out 2, you get 1 divided by 2 times 1 plus x divided by 2. But this guy is nothing but 1 divided by 2 times 1 minus parentheses negative x divided by 2. Very good. So we rewrote this function in the form of 1 divided by 1 minus a quantity, and you can basically write down a half in front of it. It doesn't change anything. So 1 over x plus 2 is written as a half times 1 divided by 1 minus negative x divided by 2. Now we can follow the pattern. Follow the pattern of geometric series, which says, hey, as long as you have the summation of x to the n, or the quantity to the nth power, if it's easier for you to see it that way, the quantity to power n, and start from 0 to infinity, as long as the absolute value of that quantity is less than 1, it is convergent to 1 divided by 1 minus that quantity. The quantity here, as you see, is x negative x divided by 2. So let us just fit that into this. You get the series. This is equals to a half the series of negative x divided by 2 to power n, and n starts from 0 to infinity. Very good. You can write some terms of this, or you can rewrite this to write it a little bit more pretty. You get 1 divided by 2, the summation of, you have negative 1 to power n, x to power n divided by 2 to power n, and start from 0 to infinity. If you multiply the denominator by 2, you get the summation of negative 1 to power n, x to the n divided by 2 to power n plus 1, and start from 0 to infinity. So what's the interval of convergence? Now for the interval of convergence, the absolute value of the quantity must be less than 1. The quantity that we have is negative x divided by 2. Let's do more algebra and try to simplify as much as we can. So first of all, the absolute value of negative x divided by 2 is nothing but x divided by negative 2, or can be simplified as absolute value of x divided by 2, or a half, less than 1. If you multiply both sides by 2, you get absolute value of x less than 2. Or your x is bounded between negative 2 and 2. So the interval of convergence is open interval negative 2 to 2. Let's recap what we did. So here we know from the geometric series x to power n, this is basically a power series, as long as absolute value of x is less than 1, it is convergent to 1 divided by 1 minus x. We used geometric series and wrote 1 divided by 1 plus x squared as a power series. Now, suppose you have this function, 1 divided by x plus 2. We want to find a power series representation for this function. Our goal is to rewrite this function in the form that we see 1 divided by 1 minus a quantity. Why is that? Because if you have 1 divided by 1 minus a quantity, it's basically a geometric series of the summation of that quantity to power n, and you just need to take the absolute value of that quantity and set it less than 1 to find the convergence interval. So if we rewrite this as 1 divided by 2 times 1 minus negative x divided by 2, this is basically the quantity that you're looking for, negative x divided by 2. So the power series representation is a half summation of negative x divided by 2 to power n, but we can rewrite this and make it into a nicer format by negative 1 to power n, x to the n, divided by 2 to power n plus 1. For the interval of convergence, just take the quantity, find its absolute value, and set it less than 1. You have a half times absolute value of x, which is less than 1, or absolute value of x is less than 2, so x is bounded between negative 2 and 2, or the interval of convergence is an open interval negative 2 to 2.